Exercise 3.8. Let I1 and I2 be the steady current passing through a long horizontal wire XY and PQ respectively. Suppose the wire PQ is fixed in horizontal plane and the wire XY is allowed to move freely in a vertical plane. Let the wire XY is in equilibrium at a height D over the parallel wire PQ as shown in the figure. Show that if the wire is slightly displaced and released, it executes simple harmonic motion. Also compute the period of oscillation. Now there are two wires, one is PQ and another one is what? XY. Okay. Now here PQ is fixed and XY is allowed to move freely. Okay. Now we are taking, let XY is at an equilibrium at a height D as shown in the figure. Okay. Now if the wire is slightly displaced and released, it will execute simple harmonic motion. We have to show that it is executing simple harmonic motion and we have to find out the period of oscillation. Okay. So now what is the force acting here is, the force acting on XY is the upward force and the downward force. The upward force we can take it as F and the downward force we can take it as mg. Okay. Now we can find out the force in XY due to the current in PQ. Okay. So we can write force due to XY, force in XY due to the current in PQ. So we can write it as F is equal to mu 0 by 4 pi 2 I1 I2 by D. Now this is the force which is acting upward. So the force which is acting upward, we are taking it as F1. Okay, F1 is equal to mu 0 by 4 pi two I1 I2 by D. We can cancel this. This can be written as mu 0 by 2 pi I1 I2 by D. This is acting upwards. So this can be written as F1 here. Now, what is the F2 force acting here? The F2 force is the downward force, that is mg. Okay, at equilibrium, these two forces are equal. So F1 is equal to F2. Okay, so we can write mu 0 by 2 pi I1 I2 by D is equal to mg. This I am going to take it as equation number 1. Now, we are going to elongate XY in the downward direction. So now XY is elongated downward to a distance y. So that can be written as F dash. F dash is equal to mu 0 I1 I2 by, the distance will change from D minus y. This is an upward force acting. Okay. Now what is a downward force? The downward force is mg only. A downward force is what? Mg. Okay. So what is a resultant force? So the resultant force is equal to Fr. Fr is equal to F dash minus mg. So this can be written as mu 0 I1 I2 by 2 pi into D minus y minus mg. We know mg is equal to mu 0 by 2 pi I1 I2 by D. Okay, so substituting here, mu 0 I1 I2 by 2 pi into D minus y minus mu 0 I1 I2 by D. Taking the common terms outside, mu 0 I1 I2 2 pi D by 2 pi, I can take it outside. So I'll be getting 1 by D minus y minus 1 by D. Okay. So this can be written as mu 0 I1 I2 by 2 pi. Taking the LCM, it is d minus y divided by d into d minus y. Okay. So this can be, you'll be getting it as mu 0 I1 I2 by 2 pi to y by d into d minus y, which can also be written as mu 0 I1 I2 y by 2 pi d square. Here we are going to take d is very much greater when compared to y. Okay, d is very much greater when compared to y, so we are neglecting the terms. Okay, so now the resultant force F is equal to mu 0 I1 I2 y by 2 pi d square. Okay, now in this case the resultant force is proportional to y, so we can write it like this. The resultant force is proportional to what? Y. So we can say the force is directly proportional to the displacement. The force is directly proportional to displacement. So it executes what? Simple harmonic motion. So we can write Fr is equal to minus k into y, because the force and the displacement are in opposite direction. You know k is equal to m omega square. Okay, so we can write force, resultant force is ma is equal to minus m omega square y. So what is a is equal to minus omega square y. This is an equation for simple harmonic motion. Okay, now the restoring force acting here is what? Fr is equal to minus ky. The restoring force is minus ky. So from that we can find it out. I am going to substitute ky in this equations. Minus ky is equal to mu 0 I1 I2 by 2 pi d square into y. Okay, this is also minus. So y and y will get cancelled. So k is equal to mu 0 by 4 pi I1 I2 by 2 pi d square. Okay, now you know this value is what? Mu 0 mg, which is mg, mu 0 I1 I2 by 2 pi into d is mg. So 1d is left over. That is like this. We can write it mu 0 I1 I2 by 2 pi d into 1 by d. This value is mg. So it is mg by d. K is equal to mg by d. What is the time period? T is equal to 2 pi by omega. Okay, so which can be written as 2 pi into root of m by k. Here omega can be written as n by k. So here m by k is what? K is mg by d. So T is equal to 2 pi into root of m by mg by d, which is equal to 2 pi into root of d by g. So this is the time period of oscillation we have found out for this question.